Our next presenter is Scott Hogg, who's actually has been actively involved in the Rocky Mountain IPv6 Task Force, has run one of the larger IPv6 events in North America, period, without a doubt. Is an author for Cisco Press title, IPv6 Security, co-author. Don't want to slight Eric. And overall a wonderful person, so I'd like to invite Scott up here to go ahead and do his presentation on troubleshooting dual protocol.
Well, thank you, everybody. So I know it's going to be, far be it from me to have to tell this audience about how to troubleshoot a network or a system or a piece of software. I think we all, troubleshoot things, almost instinctively. We've had so many, this group has had so many years of experience in IT. Troubleshooting becomes second nature for much of us. We understand that the cost of downtime of our environments can be significant to our organizations, both in monetary costs and soft costs and intangible things like loss of, or effects of reputation of our companies and customer dissatisfaction. We need to have good troubleshooting methodologies to reduce our mean time to repair. As we deploy IPv6 systems, we need to also be monitoring IPv6 so that we can be alerted to issues sooner. That factors into that mean time to repair time is not only detection of the problem, but then repair of the problem. And so we all use a scientific troubleshooting methodology, even though it may be instinctively. We go through, a process of elimination, a deductive reasoning, a component testing kind of method. We, analyze what could be the hypothesis and gather data, confirm that, create an action plan, and proceed along those lines. And we do that very much instinctively with our IPv4 networks. As we start to deploy IPv6, some things are going to change. We're going to have two things that we have to check. And because there's now two communication paths and the systems are bilingual, we have kind of twice the amount of work to do. We have twice the number of things to check. And by running dual protocol systems, we have increased the complexity of what we have to troubleshoot. And so also, as we're rolling out IPv6, the number and quantity of changes that are being made will increase. Because right now, many IPv4 networks maybe aren't in as great of a state of flux because they've been pretty much set, and they're pretty stable, and they're pretty robust. They don't incur as many changes per day. But as you're deploying IPv6, you're really deploying it, particularly even if it was on the perimeter or internally, you're going to be making lots of changes. And more things can be, issues related to human error. Computer networks and systems run really good if nobody touches them. But as you're touching them, it gives more opportunity for human error, which can introduce more problems into the system. And so we need to be able to troubleshoot IPv6 related problems very quickly. And even if we haven't deployed IPv6, because even though your organization may be just v6 at the perimeter, maybe not dual protocol internally, someone else on the internet may be going through a carrier grade NAT system, maybe having a happy eyeballs issue, maybe has v6 that's affecting the far end. But if your company is providing the service, they look to you as the one to help troubleshoot the problem. So even if you haven't been really haven't progressed far in your own IPv6 deployment, you will still be engaged in IPv6 related troubleshooting problems. For example, you may have an end user with a dual protocol system at their home. They have a Teredo tunnel. They're having trouble getting to some content on the internet. They call your help desk to try and troubleshoot this. If your help desk and your NOC is not trained in these troubleshooting techniques for dual protocol, they may not understand that something related to IPv6 is affecting that user getting to, their software as a service platform or system. So we all use a troubleshooting methodology instinctively. This is just one that I use, and it's very common, right? Baseline normal behavior. When a problem occurs, try and narrowly define the symptoms, with Kepner-Trigo or 5 Whys or what technique you have for doing root cause analysis. Gather more data, create a hypothesis, create an action plan. What's your action plan? reboot, that's the action plan. Oh, reboot didn't check it. Okay, cull down the number of hypotheses or number of possibilities and refine and go through this process. All the while, we do this instinctively, and with IPv4 networks, maybe this flowchart is pretty easy because there's only one thing, it's only one possibility. But as you get an email server that may communicate both protocols, then there's an email related problem. Is it the configuration? Is it transport? Is it something else? There's more things to check. So the number of possibilities have increased. And you don't need a troubleshooting methodology if you're troubleshooting a single part problem, a problem that has a single root cause. But when you have problems that are combinations of things affecting each other, and even though v4 and v6 are kind of independent protocols, we all know of things that can affect both, right? And there is some mixing of how systems negotiate v4 or v6 connections, and we need to be able to be faster at troubleshooting. And because the increase of the complexity of the environments, we now need to go back to traditional troubleshooting methodologies that will allow us to make progress on troubleshooting multi-factor problems. Also, we're used to troubleshooting the IPv4 stack, and we know ARP is really a separate protocol. IGMP and ICMP are really independent of each other. But within IPv6, we need to be keenly aware that there are sublayers within the network layer. There's a dependency of MLD and the neighbor discovery protocol on top of ICMP v6, and they use multicast, not broadcast. So these sublayers, we change the way we troubleshoot, right? Because if ICMP v6 isn't working for some reason, or if multicast isn't working right, or something at layer 2 may be affecting that, that's going to affect other things on top of that. And so you might have an entry in the neighbor cache, or you might not have an entry in the neighbor cache, and that's going to guide your troubleshooting behavior. So, things at the application layer, troubleshooting things at the application layer won't change. Troubleshooting physical layer problems won't be changed by the introduction of IPv6. But now we have two paths up and down this stack, and applications may choose to make connections over one or the other. For example, let's say you go to a website and you get back the elements of that page through the web browser. Maybe there are some components of that web page that get served over IPv4 connections. Maybe some components of the web page get served up over IPv6 connections. So you kind of have some asymmetry in the protocol stacks based on a particular application, because some content's coming from one server that might be dual protocol and other systems v4 only, and as the browser reassembles the page, some content isn't being shown. So now you see that the complexity of the system now and the dual protocol paths cause us to change our troubleshooting methodologies and be keenly aware of how the v4 and the v6 sub-layers affect each other. We capture packets and we sniff, span, use packet monitoring switches, use taps and things like that. But maybe when we have to troubleshoot more advanced application things. Because when you're a network engineer, what do? You ping. Okay, I can ping. Not my problem. Must be the app. Right? It's not the network, it's the app. Well, sometimes it's the network. So we probably don't use sniffers all that much unless we're troubleshooting maybe an upper layer problem. But as we start to work with IPv6 more, we are going to have to do more protocol analysis, because how do you know whether the traffic path was v4 or v6? Well, you look in DNS. Well, DNS, I got back an A record and a quad A record, so I assume my application made the connection over v6 as a kind of built-in preference of towards IPv6, but maybe not. Maybe it was a happy eyeball situation. Maybe I'm using Safari, or depending on the operating system, or maybe the operating system has built in, happy eyeballs type concept, at the operating system level. So the application, whether that's happy eyeballs or not, may have, selected v4 or v6. How do you know for sure? The end user, we don't want the end user to have to know whether connections were being made over v4 or v6. They just want to be able to go to Facebook. They don't care how they got there. But as part of our troubleshooting, what's the real conclusive way to determine whether the connection was made v4 or v6? We use a protocol analyzer. So we'll be busting out the protocol analyzer more often in a dual protocol environment. Many popular IPv6 capable protocol analyzers that are out there that can help us find that needle in a haystack. So also with IPv6, we have to get really good at capture filters, not just display filters, but capture filters, because we're looking for those couple of v6 packets in a mountain of IPv4 traffic, and we're looking for something very specific. Well, in order to reduce the amount of traffic that we're capturing, we need to be good at those traffic filters, to gather exactly what we want. So we need to be good at capturing the packets that we want, looking at those, and seeing that there could be interaction conflict. But if you just captured only v6 traffic, you may not see the whole picture, because in the time domain of all the packets that went by on the LAN, there could have been v4 packets that affected the v6. You may not have seen that the DNS query took place over v4 or over v6, and what the response came back at, And so I suspect we're all going to be using protocol analyzers a lot more, as time goes on. Speaking of sublayers, I like using Cisco Discovery Protocol to help me determine connectivity between devices, and or LLDP or Extreme Discovery Protocol. These layer 2 protocols can help us determine some of the physical connectivity between devices and share some information between the network devices about their topology if we don't have a good network diagram. I do encounter lots of customers that don't have very good network diagrams, and I kind of rely on CDP to kind of help me put things back together. Well, CDP and these protocols have typically been just IPv4 only protocols, but now they're starting to get some IPv6 capability in them. So, so as we start to upgrade versions of code on our network devices, we'll get some v6 capability into these layer 2/3 protocols that'll help us troubleshoot things between the network layer and the data link layer. When the host sends the router solicitation message, when it first boots up, it does that to try and find out the routing advertisement. And really the routing advertisement is the key message that gives indication to the hosts on that LAN about how they're supposed to go about getting their address, determining the MTU size, who they should use as their default gateway, things like that. And the routing advertisements contain a lot of really useful information. Well, depending on the settings in the routing advertisement, it could have an undesirable effect on the hosts on that LAN, not to mention, rogue RA packets and things like that. So it may be helpful for us to capture the routing advertisement at the host to see what really the router sent and to validate the behavior of the host. As we check the nodes, we need to validate, well, what was the method that it went about to get its address, its global address or what have you? Is its link local address working well? Can we, communicate with the default gateway? Can we communicate off-link? Can we, communicate locally to the default router with a link local address? Can we communicate with the global address? Is v4 working too? So validating next hop for v4 and v6, we're going to be doing lots of pings. Ping over v4, ping over v6, DNS lookup, dig, query, and things like that. So we'll be doing lots of these things. And any place where we statically define addresses, such as servers, other systems, it's prone to human error, and it's hard to see. I was telling Yuri from Nefo 6 a story about I was helping a customer, and they were trying to enter in an IPv6 address, and they were having problems because the syntax was erroring out. And I was looking at the IPv6 address, and I realized that the person who was entering in the address, I was like, man, those are pretty fat-looking zeros. They were using a capital O instead of a 0, and that's why it wasn't taking the address. Anyway, so Neighbor discovery is the IPv6 equivalent of IPv4's ARP. So it's important that we check the neighbor cache to validate that mapping. And the commands for different operating systems where we can check that. It's good to know who our neighbors are and look at ARP and match that up and validate that. Even though two systems may have each other in their neighbor cache, they still may not be able to communicate on the LAN. I ran into a situation where there was two different operating systems and they had a firewall as their default gateway. They were able to both communicate out to the internet, but they couldn't communicate between themselves. They couldn't ping each other, yet they had each other in the neighbor cache. One system, the way it was configured, had the /64 on link on the local LAN. The other system, the way it was configured with a static address, the operating system didn't automatically install a /64 prefix for the LAN. It sent all its packets to the default gateway. So when the ping echo request came from this machine to this machine would respond but send it up to the default gateway. The firewall wouldn't take the packet in and out the same interface. It would drop it. Therefore, the echo reply never got back to this machine, and vice versa. Once this operating system, we added a static route for the /64 to be on link, then they could communicate with each other. So you'll run into situations like that, and the way I was able to make progress and figure out what was going on was to use a protocol analyzer to analyze the packets on that LAN. We need to do end-to-end troubleshooting, and we're going to do end-to-end troubleshooting over v4 and v6. I kind of wish I had a ping that was like a multi-ping that would ping over IPv4, ping over IPv6, ping by name, ping by IP address, do all these things all at once. So I think we may have, tools that could do trace routes and pings and validate a lot of end-to-end connectivity all at once, because we're going to have to run multiple commands to gain insight into why we can't communicate end-to-end between some systems. But there are a lot of other tools like the ones I mentioned here on this slide that can give us more information than just a ping. They can tell us the traffic path. And the traffic path is important because we're going to be troubleshooting more often with tunnels. And when the packet goes into the tunnel may not always take the shortest physical path. It goes into the tunnel. So, a packet from San Jose to Tokyo could look like it's one hop, but it's not, right? It lays on top of a routed topology that uses many hops. So tunnels are more difficult to troubleshoot than native v6 connectivity. So over time, we'll have a v4 network, we'll layer on we'll add tunnels, we'll layer on IPv6. Eventually, we'll have to take those tunnels down. But it's in that period of time when we may have v4 tunnels and starting to roll out native v6 that the tunnels could cause problems. The 6 and 4 tunnels converge on top of the IPv4 topology. If there is instability in the IPv4 routing topology, that'll cause instability for our v6 traffic as well. So we have to understand kind of how that tunnel gets layered on top of that layer 3 topology, v4 topology. Tunnels can add latency, could cause some asymmetry potentially. That could cause application timeouts, reconfigurations, out of order packets, and some applications may not handle that. The tunnels, of course, reduce our MTU size. We all know many IPv4 applications that don't work well with path MTU discovery, but because the IPv4 routers coddle the applications and do fragmentation on behalf of the source, those applications get away with that. But with IPv6, the routers don't do the fragmentation. The applications are going to need to be rewritten. So we're all going to be troubleshooting lots of path MTU discovery issues as applications realize, I guess we do have to fix our path MTU discovery issues once and for all. We can't avoid it any longer. Manually configured tunnels could be misconfigured. Automatic and dynamic tunneling techniques can also cause problems, as we all know. There's things we can do on routers, with NBAR and NetFlow. Routers can do packet captures as well, but you have to be careful, right? You can do anything on your last day at work. So you might want to do a router packet capture if you wanted, if you knew that was going to be your last day at work. You got to be careful. You don't want to, it's like the Heisenberg uncertainty principle, right? By monitoring something, we are affecting its behavior, so we have to be careful about adding extra load to a system. You know, set up an ER span or set up a RSpan VLAN, send it a gig of traffic, see what that does to your processor. You'll turn it off when you're done. We can use IPSLA, and these tools are V6 capable now. So the tools that are embedded in the network elements to help us do troubleshooting, these are V6 capable and V6 aware. So we want to use these tools as tools in our bag when we're troubleshooting these multi-protocol issues. And we have to verify both the unicast and the multicast routing tables for V4 and V6 and look at both. We need to verify DNS, because really DNS is what's going to give the clue to the application whether it should make a V4 or a V6 connection. So we need to get good at, you know, dig and NSLOOKUP and host commands, particularly dig. But you may want to check other DNS servers on the internet besides your own. You may just check your own, you may just be getting your own cached results. You need to look outside to see what the perspective of something is from another location. So you may want to use one of Google's public DNS servers, and you may want to do queries over V4 and V6 and do specific queries or specific digs to check these things. You may want to look at Hurricane Electric's Google whitelisted DNS servers or their DNS servers as well over V4 or V6 and check these things. But getting that external perspective is valuable, particularly for organizations that are doing an internet edge deployment where they're deploying IPv6 at their internet perimeter, but their internal network systems are V4 only. So how do you troubleshoot something if you only have V4 access? You need a testing point out on the internet that can generate some V6 traffic towards you. If you didn't want to, you know, you put in a URL into your browser and you don't know whether the connection took place over V4 or V6. Maybe you want to specify the V6 address explicitly. You could do that with this technique of manually defining the V6 address by putting it into square brackets. Other things like the show IP add-on for Firefox may give you a clue as to if you actually made the connection over IPv6 down in the lower left or lower right corner. It would tell you what address you're connecting to. There's an IPv6 foo tool for Google Chrome that's very useful. Just kind of shows you how that works. You may need to also leverage BGP looking glasses that are outside your organization to help troubleshoot your routing issues. Then there are many looking glasses today that are V6 capable. So leverage that to help you get that outside internal, outside perspective of what you're offering that's dual protocol capable on the internet. There's utilities out there that you can go to, websites you can go to over V4 or V6, type in your URL, it will do a check back to you and validate that you really do have solid V6 connectivity. Although many of these tools are HTTP only, if you're deploying an IPv6 website that's SSL, uses HTTPS, you may need to use a more advanced tool to give you that external view and validate that the certificate is correct and everything like that. There's IPv6 test, IPv6-test.com, validate PHP can give you a view of your domain or your website and tell you, the statistics. I often advocate if you don't have an external testing point, you should, put a server in an IPv6, capable co-location facility like a Hurricane Electric facility. Give yourself that test point. Give yourself a point of testing that has solid IPv6 connectivity that you can test from, and that would give you that external perspective. There are many other websites that you can go to that checks your V6 status and checks your V6 connectivity and things like that. IPv6-speedtest.net can even do an IPv6 speed test, for example. So there's more websites, and there's more websites coming every week that allow you to facilitate this type of testing. So the bottom line here is I'd like you to think about your troubleshooting methodology that you use today for IPv4 and think about how IPv6 changes that methodology. Continue to, as you're troubleshooting, document your actions and results, because that documentation will help you make progress on multi-part, more complicated scenarios. Leverage the tools that you have available, and now you do have tools that are dual protocol capable, and use a protocol analyzer to really get down into what's happening at a protocol level. And strive to understand the protocols that you're troubleshooting and how they behave or how they could misbehave. And having all of this prepared and ready to go ahead of when you might encounter a problem will help you reduce your mean time to repair. Okay. Yeah, any questions? Joe. SolarWinds? Yeah, SolarWinds is V6 capable. Yeah, I think most of the time it boils down to troubleshooting and using DNS and pings and things like that. And the protocol analyzer, I think, gives you more benefit to troubleshooting end-to-end problems. But those utilities do query the new modern V6 capable, the consolidated MIBs, and give you good information about capacity planning and can alert you to the problems, up-down status and things like that, yes. Mm-hmm. Any other questions? Okay. Thank you very much. Oh, thank you very much.